are watching Darasa Online.
Hi students, my name is Nafta Lucas Makumbire. I'm teaching chemistry. Today I want to present to you the topic which is called carbonyl compound. And the subtopic that I'm going to focus today will be properties of carbonyl compounds. But specifically today, I'm going to focus more on the chemical properties of carbonyl compounds. So we need to discuss what is it all about, and I am sure that by the end of this period, you are going to apply the chemistry knowledge, principles, and the skills in order to solve day-to-day life problems. So you are welcome for this presentation so that you can get that knowledge of solving different problems relating to this particular area. Now, starting to, for the case of carbonyl compound, we need first to introduce what is it all about. You can ask yourself a question. What is a carbonyl compound? A carbonyl compound is any organic compound containing carbonyl group as a functional group. So this is the meaning of carbonyl compounds. Any compound containing the carbonyl group like this one, it is called carbonyl compound. Now, because this is the functional group, I can also ask a question there. What do you understand by functional group? Are you able to tell the meaning of that? Functional group, this is an atom or group of atoms which carry chemical characteristics of organic compound. That is the meaning of the functional group. So this carbonyl group carries all chemical characteristics of these compounds, which are called carbonyl compounds. Now from there, my dear students, carbonyl compounds have two classes. Now let's see each class so that later we can deal with the chemical properties of this compound. Remember, I have told you that specifically today I'm going to present to you the chemical properties of carbonyl compounds. Now, my dear students, we have two classes of carbonyl compounds. The first one is ketone. The second one is aldehyde. The two classes differ from each other depending on the position of carbonyl group. That means the two compounds or the two classes are isomers to each other. Starting with the first one, ketone. What is ketone? If I tell you to define ketone, what are you going to say? Or if I give you some examples on the board, can you tell the meaning of it? Now let's have these examples. This is example 1. It contains carbonyl group. Now, if I ask you to define a ketone using this example, can you tell it, my dear student? Another example. This is another example. Now, from here, also we can see another one. So the first example, the carbonyl group is present between the two alkyl group. We have methyl group and another methyl group. And also when you come to this particular part, this group is present between two groups. We have phenyl group and another phenyl group. These are allyl groups. And also here we have allyl group and methyl group. So by using these three examples, we can generally say that ketones, these are carbonyl compounds containing carbonyl group between either two alkyl groups, just like the way you can see in the first example, or two allyl group, just like you can see in this example, or the carbonyl group is present between one alkyl group, which is this one, and one allyl group, which is this one. So that is all about ketone. Now coming to the second class. The second class is aldehyde. I'm also going to give you some examples so that you can define it. Examples. Number 1, we have this one. This is example 1. Number 2, we have this one. That is example 2. The first example contains 2 carbon atoms, so this is ethanol. The second one contains 3 carbon atoms, so this is propanol. So you can see the position of the carbonyl group. If I tell you to define it there, you can simply say aldehyde is the organic compound containing carbonyl compound bonded to at least one hydrogen atom, as you can see. So that is all about ketone and aldehyde as we are reviewing this particular part of our discussion today. Now, my dear students, apart from that, we are coming to see the carbonyl compounds. As I say, carbonyl compounds contain the carbonyl group. So from there, we can go directly to the presentation that I said, the chemical properties of carbonyl compounds. In today's presentation, I'm going to review the 2 chemical properties. The first one will be nucleophilic addition reaction, as well as chemical distinguishing test, as we are going to see later. Now, starting with the first one, nucleophilic addition reaction. Nucleophilic addition reaction. Now, I'm sure that you remember the definition of a nucleophilic addition reaction. If I tell you to define, what is it all about? There you are, my dear student. I'm sure that you can tell me. Nucleophilic, nucleophile, addition reaction. There are two terms there to define. When we talk about nucleophilic addition reaction, we are referring that this is the type of organic reaction whereby the nucleophile is added first, followed by the electrophile. Now, the carbonyl compound, this one contains carbonyl group. Now, when you look at this functional group, this is where the chemical properties are taking place. The oxygen and the carbon differ in terms of electronegativity. Oxygen being more electronegative than carbons, it becomes negatively polarized because it will take all the electron pair from the bond. So this one will become negatively polarized. And the carbon atom, because it is less electronegative, it loses all the electron from the bond because they are taken by oxygen atom. This one will become positively polarized. So you can see there. Now, because this carbon becomes positively polarized, that means this is electrophilic. So this carbon is electrophilic. Electrophile. Electrophile. All positively charged species are electrophile. That means they have deficiency of electron. Therefore, they need a pair of electron to stabilize them. So this carbon is electrophilic. So if this carbon is electrophilic, that means it is a good site for the nucleophile. This carbon. Carbon is electrophilic. Hence, it is a good site for nucleophile. The nucleophile, this one is negatively charged. That means it has extra electrons. It can donate or supply the pair of electron to this carbon atom so as to stabilize this positive charge. That is electrophilic. Now, from there, that is nucleophilic. That means the nucleophile will be added to this electrophilic carbon. Now, why additional reaction? Additional reaction here can be explained by the double bond here. We have the sigma bond, this is the sigma bond, and this is the pi bond. Now, the presence of this pi bond, or this double bond, for the carbon of carbonyl group, make the carbonyl compounds likely to undergo additional reaction because double bond, the presence of the pi bonds, make all organic compound to undergo additional reaction. So from that point, I have explained why a nucleophilic and why additional reaction. That is important for you to remember. Now, from there, my dear students, because of this positive charge, the nucleophilic additional reaction, the amount of the positive charge which is present on the carbon atoms explains the reactivity of carbonyl compounds towards the nucleophilic additional reaction. Now, from there, this positive charge, the more the positively polarized carbon in the carbonyl compound, the more likely the carbonyl compound will undergo additional reaction. Now, to explain the amount of the positive charge which is present in the carbon atom, this is explained by the strength of the positive inductive effect. I hope, my dear student, you remember when you discuss this topic in the class, in the introductory part about the factors affecting organic reaction. You discuss one of the factors is inductive effect. So when you talk about positive inductive effect, I'm sure that you remember that there is a partial supply of electron towards the functional group. So this positive charge will explain the reactivity of the carbonyl compounds towards nucleophilic additional reaction. So the stronger the positive inductive effects toward this carbon will make that organic compound less reactive towards nucleophilic additional reaction. Why? Because if there is a stronger positive inductive effect, that means more electrons will be supplied to this positively charged carbon, making this less electrophilic. If it becomes less electrophilic, that means it will also become less reactive towards nucleophilic additional reaction. Therefore, those carbonyl compound which experience stronger positive inductive effect will be less reactive towards nucleophilic additional reaction. So this can be used to explain the reactivity of the two classes of carbonyl compound. That means the reactivity of aldehyde and the ketones towards nucleophilic additional reaction. They differ in each other. Now also, it can be used to differentiate between the reactivity of aldehydes among themselves or reactivity of ketones among themselves. Now, higher members of the aldehyde will experience stronger positive inductive effect due to the presence of a longer chain of alkyl group. So this one will be less reactive. Why? Because the electrophilic carbon will be made less reactive. Therefore, these compounds of higher members of aldehyde will be less reactive towards a nucleophilic additional reaction. So lower members of the aldehyde will be more reactive because they experience a less positive inductive effect. Therefore, they will be very reactive towards nucleophilic additional reaction. Now, from there, my dear students, you can be able to tell the differences in the activity between aldehyde among themselves. But for the case of aldehyde and ketone, also here we can get the differences by which is explained by the strength of positive inductive effect. Why the differences? When you explain the differences here between aldehyde and ketones in terms of reactivity towards nucleophilic additional reaction here, number one, we are going to deal with the strength of positive inductive effect. Now ketone, because it consists of two alkyl groups or two allyl groups which supply electrons towards the positively charged carbon, which is electrophilic, will make the carbon which is positively charged to the carbonyl compound less electrophile, making the ketones less reactive. So ketones are less reactive towards nucleophilic additional reaction because they experience stronger positive inductive effect. That is reason number one to explain the unreactivity of ketone as compared to the reactivity of aldehyde. But also number two, steric hindrance. Ketone, because ketone also it experiences, because there are two alkyl groups. These two alkyl groups, if they are large in size, they exert steric hindrance towards the electrophilic carbon, making it less reactive towards nucleophilic additional reaction. But for the case of aldehyde, because the positive inductive effect is exerted by just only one alkyl group from only one direction, therefore it is more reactive as compared to the ketone. Now, my dear students, from there you can be able to tell the differences in reactivity between ketones and aldehyde. Now, from there we can also see there is another very good question to ask ourselves. How can you differentiate between the carbonyl compounds from other organic compounds? That is also a very good question to ask ourselves before we go to some examples. How to distinguish between carbonyl compound from other organic compounds? It is also a very important part to know how to distinguish carbonyl compounds from other organic compounds. Now, we have a reagent which tests for the presence of carbonyl group. This reagent is called Brady's reagent. or it is called 2,4 dinitrophenyl hydrazine. Now, any organic compound containing carbonyl group react with this compound to give a yellow crystal. So when the yellow crystal is observed in the reaction, now you can note that the carbonyl group is present on that particular compound. So here, now we can see some examples. This compound is written this way. This is 2,4 dinitrophenyl hydrazine, or the Brady's reagent. Now, how does this compound react with the carbonyl compounds? Examples. This compound will react with the oxygen atom from carbonyl group and with the hydrogen atoms to form water. That means the oxygen atoms and hydrogen atoms will combine to form water. That means here, if we arrange it properly, it will be this way. Oxygen atom from carbonyl group and hydrogen atom from nitrogen will combine and to form water, and this is condensation reaction. So here we are going to form this double bond with nitrogen, and water. This one is a yellow crystal. It will be observed. So this one is propanone 2,4 dinitrophenyl hydrazone, which is a yellow crystal, will be observed when this one reacts with the ketone. Now, from there, we can have the second example for the case of aldehyde. Let's take example of ethanol reacting with this compound. What will be the product? This as well will give water. So the product will be once again, this is the yellow crystal that will be observed. But other organic compounds do not react with the Brady's reagent. That means they will give a negative test. So if you are going to be asked the question to compare the carbonyl compound given, either ketone with other organic compounds or aldehyde with other organic compounds, you can use this reagent, which is the Brady's reagent. Thank you very much. We'll be back after a short break. Stay tuned. Welcome back, my dear students. Now, from there also, we can come to distinguish between how to distinguish we have seen in the first part how to distinguish carbonyl compound from other organic compound. But also, you can be asked to distinguish between ketone and aldehyde. How can you distinguish? Now here, there are two reagents you can use. Reagents. Number one, we have silver mirror test. Silver mirror test. This silver mirror test uses the reagent which is called ammonico silver nitrate, or it is called Tollens reagent. So Tollens reagent or ammonico silver nitrate, which is given the formula here, can be used to distinguish between ketone and aldehyde. Now, why the differences between them? Aldehyde is a strong reducing agent. And this compound here is a mild oxidizing agent. So this compound will oxidize aldehyde because it is a strong reducing agent into carboxylic acid, which will further react with ammonia to give ammonium carboxylate. And why this aldehyde is a strong reducing agent? It's because it contains hydrogen atom to the carbon contained in the carbonyl group. But ketone, because it lacks hydrogen atom to the carbon contained carbonyl group, is not a strong reducing agent. So it is not going to react with this reagent. So that is how we can differentiate. So take an example of aldehyde aldehyde gives positive silver mirror test. Example, take example of ethanol. This is the ethanol reacting with that compound. In the presence of water, because this is aqueous. Now, this aldehyde, because it is a strong reducing agent because of the presence of hydrogen atom, will be oxidized into carboxylic acid. But because of the presence of ammonia in the solution, it will react further with ammonia to give ammonium carboxylate. So here we are going to get ammonium ethanoate, which will be coming from carboxylic acid, which is oxidized by this reagent, And that carboxylic acid reacts with ammonia, which is present in the solution, to give this one. And because this is the mild oxidizing agent, it will be reduced to silver. And this is silver mirror. Also, there will be formation of nitric acid and some ammonia. So the presence of silver mirror distinguishes that compound which is oxidized is aldehyde. But when we take, for example, this one, propanone, reacting with this reagent, there is no reaction because ketone resists oxidation. It lacks hydrogen to the carbon atom containing the carbonyl group. So this one resists oxidation. So here you can distinguish between that one by using the silver mirror test. The second way of distinguishing between ketone and aldehyde is by using Fehling solution. Fehling solution, which is a mixture of copper 2 sulfate and sodium hydroxide. Now, copper 2 sulfate contains copper 2 ion. This copper 2 ion, because this also is a mild oxidation, so copper 2 ions will be reduced because it is a mild oxidation itself will be reduced into copper 1 oxide, which will look as a brick red precipitate. But the aldehyde also will give positive Fehling solution test, but ketone does not. Why aldehyde? Because it is a strong reducing agent. An example, let's take the same example. With this mixture with the Fehling solution, this one will be oxidized. This aldehyde will be oxidized into a carboxylate salt. Because this is a strong reducing agent, it will be oxidized into sodium carboxylate. Because there are two carbon atoms here, it will be sodium ethanoate, which will be written this way. And the copper 2 ion, which is present in this copper 2 sulfate in the solution, will be reduced into copper 1 oxide. So this one will look as a brick red precipitate. The presence of this brick red precipitate indicates that the organic compound that was in the solution is aldehyde. But when we take the same example we've used here, ketone, there will be no reaction. Why there will be no reaction? Because ketone resists oxidation. Why? Because it lacks hydrogen atom to this carbon carrying the carbonyl group. So that is the second way of differentiating between ketone and aldehyde. So if you'll be asked in the national examination question, for example, to tell the differences between ketone and aldehyde, you can use the two reagents to differentiate. From there, my dear student, the last thing that you can see here, the last important question you can ask yourself here, how? Sometimes you can be given the question to differentiate between aldehyde and aldehyde, or to differentiate between ketone and ketone. What are you going to do? It is very simple. There is a test here which is called iodoform test. The iodoform test is the chemical test which tests for the presence of terminal methyl group. So if you are given, for example, to differentiate between aldehyd and aldehyde, you just look which one contains the terminal methyl group. That one will give the positive iodoform test. And the iodoform test, this is the mixture of iodine and sodium hydroxide. The mixture of iodine and sodium hydroxide. Now, for example, for the case of aldehyde, only for aldehyde, only ethanol for the aldehyde, only ethanol will give the positive iodoform test because it is the only one which contains the terminal methyl group. But the rest of the aldehyde will not give the positive iodoform test. So you can be told to differentiate between ethanol, for example, and propanol. Ethanol will give positive iodoform test, propanol will not. Example here. This is the iodoform test. This ethanol will be oxidized into carboxylated salt. Now, because there are two carbon atoms here, this will be sodium carboxylate. And, the terminal methyl group that we're talking about is this one. So this one will form triiodomethane, which is a yellow precipitate. A yellow precipitate to indicate that organic compound contains terminal methyl group. Now, from there, the remaining carbon with this carbonyl group will be oxidized into carboxylated salt. Now, sodium, it will be sodium methanoate because there is only one carbon here. Plus sodium iodide and water. But when you take, for example, propanol, this propanol, when is tested, mixed with the mix of iodine and sodium hydroxide, there is no reaction. It gives negative test. Why? Because ethanol, propanol, does not contain the terminal methyl group. What is present here is the ethyl group. So this one does not react with that mixture. The same applies to ketone. So for the case of ketone, the methyl ketone will give positive iodoform test. When we talk about methyl ketone, we are talking about a ketone with at least one methyl group will give a positive iodoform test. But that one without the terminal methyl group won't give the positive test. It will give the negative test. So that is how you can distinguish between aldehyde and aldehyde. Or you can be able to distinguish between ketone and ketone. I'm sure that, my dear student, you are following. Now, from here, we can look some possible examples, some possible questions that you may meet in this particular area. Now, the possible questions that sometimes you can meet in this particular area. Here we have some examples. This is the first one. Now, the first question says, first one, lower members of aldehyde are more reactive towards nucleophilic additional reaction than higher members. Explain. Now, my dear students, that first example requires the knowledge from the first part that I used to introduce, that lower members of aldehyde are more reactive, yes, because they experience less positive inductive effects. Therefore, the carbon which is positively polarized will be more likely to undergo nucleophilic additional reaction. But higher members of aldehyde will experience stronger positive inductive effect. If that is the case, this stronger positive inductive effect will make the positively charged carbon of the carbonyl group of the halide to be less electrophilic. In that way, it will be less reactive towards nucleophilic additional reaction. That is the answers for the first part. I'm sure that you remember, you can be able to answer that one. Now, for the second part, says, although both aldehyde and ketones contain carbonyl group, ketone is less susceptible to nucleophilic attack. Explain. Now, my dear students, that question is also very simple. I explained it during the introductory part of this particular presentation, when I differentiated between the reactivity of aldehyde and ketone. I said that, if you remember, ketones, because they experience stronger positive inductive effect from two alkyl group. Now, these two alkyl group, they will make the carbon atom, which is positively charged to the carbonyl group, less electrophilic. In that way, they make the ketone to be less reactive towards nucleophilic additional reaction. But also another case, the ketone will experience steric inverse, because the two alkyl group, if they are larger in size, now they will give the carbon atom, which is positively charged, of the carbonyl group, the steric hindrance to prevent the nucleophile to come and be added to the carbon atoms. So that is the reason to explain why ketones are less reactive towards electrophilic additional reaction as compared to aldehyde. Because for the case of aldehyde, it receives positive inductive from only one direction, only one alkyl group. Therefore, it is reactive as compared to that one. From there, we can come to this one. We can come to this question. Arrange the four organic compounds according to the ability of undergoing nucleophilic additional reaction. Now, how can you arrange? My dear students, arrange those compounds here. It is very simple. I have told you here that when you compare the reactivity of aldehyde and ketones, aldehyde are more reactive than ketones. So in these questions, you are given the mixture of aldehyde and ketone. This is the ketone, this is aldehyde, this is ketone, this is aldehyde, this is ketone, this is aldehyde. So there is a mixture of ketone and aldehyde. So when you arrange, you start arranging the aldehyde because are the ones which are more reactive than ketone. But the reactivity of aldehyde are different. Why? Because I have told you that higher members are less reactive because they experience stronger positive inductive effect than lower members. So lower members of aldehyde are more reactive because they receive less positive inductive effect. So starting to arrange with us with the aldehyde. Now, which one experiences less positive inductive effect? It is this one, ethanol. So this is the most reactive one. So that is the most reactive of all. From there, go to another halide. Here we have this one. This is ethanol. And also we have propanol. Which one? Propanol has got 3 carbon atoms. So this one will experience stronger positive inductive effect than ethanol. So the ethanol will experience less positive inductive effect. So this one will be more reactive as compared to propanol. The last propanol is this one. So we write it as it is. We have finished with the aldehyde. Now we go to the ketones. The reactivity of also ketone differ from one another. Those members with large alkyl group are less reactive compared to those with less alkyl group in ketones. So the ketones here have this one. We have another one, this one as you can see, and another one here. So you can look which one contains less number of carbon atoms. When you look at this example, this one, and this one. Now this one contains fewer carbon atoms. There are 2 alkyl groups here, yes, but there are only 1 carbon atom. So this one is more reactive as compared to the rest of the ketones. Followed by we have remained with the two ketones, this one and this one. Here we have acyl group, ethyl group. But this one contains ethyl group and methyl group. This one contains fewer number of carbon atoms as compared to this one. So this one will be more reactive as compared to this one. Then the last reactive one will be that one. So that is one of the questions that we may meet from this particular presentation in the examination that are coming. Now, there is also another question, 1D. Draw the structure of ketone that is an isomer of butanol. Now, my dear students, you know, the two classes of carbonyl compound are isomers to each other. So if you are told about butanol, butanol is an aldehyde. Now, that butanol, the isomer of it is a ketone. So for the case of D, butanol, which is written as this one. Now the isomer of this one is ketone because the two classes are isomer to each other. So here we are going to have this one. This is called 2. It is called 2-butanone. So you can look the differences in the position of carbonyl compounds. They are the same. They are isomers to each other. When you count the number of carbon atoms or the number of atoms in both, they are the same. So that is the first example. Now, my dear students, there are also some more examples here. This example 2. I'm sure that you can even do it yourself because this question says, give the chemical test to distinguish propanol from 2-propanone. Here, what are you required to distinguish? You distinguish between aldehyde, propanol is an aldehyde, and propanone is a ketone. So here you give the differences between aldehyde and a ketone. And I've given you two chemical tests. The first one is silver mirror test using Torres reagent. The second one is a Fehling solution. Propanol will give positive test to the Fehling solution as well as silver mirror test, but propanone will not. Do it yourself. There you are, my dear students. But B explains, B says, explain briefly why aldehyde is easily oxidized while ketone does not. Now, my dear student, if we were together from, I'm sure that we were together from the first presentation, in the introductory part of the introduction, I said aldehyde is easily oxidized because it is a strong reducing agent. Why strong reducing agent? I said because the carbon containing carbonyl group is bonded to hydrogen atom. So that one makes that compound to be strong reducing agent. So it can be easily oxidized to oxidize. But ketone resists oxidation. Why? Because the carbon with carbonyl group is lacking hydrogen atom. So that's why that one does not. Another question here, my dear student. Which is a good reducing agent? Aldehyde or ketone? Explain your answer. The same answer that I have given. Reducing agent is aldehyde. Why? Because of the presence of the hydrogen atom bonded to the carbon with the carbonyl group. So these are the questions that even yourself you can try. We have also another example here for the third question. Now you can take the pen and write these questions and try to do them yourself. If you have any problem, you can contact me. There is the contact number which is displayed on your screen. There is no problem with that one. The example of this question, explain what will be observed with the aid of chemical equation for each of the following. For example, Roman 1, butanol is mixed with a mixture of iodine and sodium hydroxide. It's just to guide you. How are you going to solve this question? Butanol is aldehyde, and this is the iodoform test. Remember iodoform test? Test for the presence of terminal methyl group. So you just write the compound, the structure of it, and you look, is there any terminal methyl group? If it is there, it will give positive. test as we have discussed it. If it is not there, it will give negative test. So that is a guide to you. Acetone is reacted together with 2,4 denatophenylhydrazine. What will happen? Acetone is a common name for 2-propanone. Now, this one, because it is a carbonyl compound, it reacts with this Brandeis reagent or 2,4 denatophenylhydrazine. So you can write the chemical equation yourself. Also, my dear students, you can use this example. With the equations, with the aid of chemical equation, distinguish between the following compounds: ethanol and ethanol. This is the organic compound, this carbonyl compound, and this is ethanol. I have given you the reagent to distinguish between carbonyl compound from other organic compound. You can use it. Try it yourself. There you are. 2-pentanone and 3-pentanone. These are the two ketones. How can you distinguish between ketone and ketone, my dear students? It is very simple. I have given you the alternative way of solving this problem. You can use the iodoform test. You just write the structure of the compound and you see which one contains the terminal methyl group. That one will give positive iodoform test. So you can try to do those questions. So my dear students, today we had a very nice presentation about the chemical properties of carbonyl compound. Now, it is important for you to remember how the carbonyl compounds undergo nucleophilic additional reaction. To explain why nucleophilic, why additional reaction. It is important for you to know that. But also it is important to remember and memorize how to distinguish between the classes of organic compound, between ketone and halide, but also to distinguish between carbonyl compound from other carbonyl compound, but also to distinguish between aldehyde and aldehyde if given, ketone and ketone if it is given. You can face challenge if you are not memorizing the reagent, the chemical reaction. It will be very simple for you if you memorize the method of preparation of different organic compound as you have studied in the class, as well as the chemical properties. This one will give you a larger number of reactions. So long as you know the mechanism, it will be very easy for you to solve these problems. Now, I want to take this opportunity to thank you for connecting with me in this very interesting program. So in the next session, in the next lesson, we are going to continue with the discussion about the chemical properties of carbonyl compound. And also we are going to solve some more questions, including the techniques of making organic conversion, because that is also another problem. Thank you very much for watching. Remember, these carbonyl compounds are very useful in our life. If, for example, benzohaldehyde is an aldehyde, we use it in the perfume industry to make perfumes. Methanol, when you go to the biology laboratory, there, the samples which are there, they are preserved by methanol or formalin. Methanol can be used to make vaccines, to kill viruses, can be used to make chemicals, to kill bacteria. You see, so it is very, very important. Even vanilla is just the application of this carbonyl compound. So next time we are going to see more. Thank you very much for this time, and bye.